Good morning, everyone. Shall we open the window or leave the door open? It smells like work already here, and we haven't even started. So let's see how this will be in 1 hour. My name is Jaron Beal. I'm not sure if some of you know me already from the machine learning lecture or some other seminars or lectures. I'm really looking forward to give this lecture to you. It's about my favorite topic, recommender systems. So systems that recommend items to you. All of you, I'm pretty sure, have been in contact with recommender systems one way or another. If you use Netflix, if you use Spotify, if you use Amazon or TikTok or whatever, all these systems have recommendation engines that suggest items to you, typically. And what I'm interested in first is, let me see if this works. How satisfied are you generally with recommendations? We make this a bit interactive. If you could get out your phones or your tablet or computer and just go to this website, menti.com, type in this code, and tell me how satisfied are you with recommender systems.
Can we scan the QR code?
You can try, but probably it's not working, right? It seems like some part is covered. Oh, wait, yeah, try if it works. Because it's not my computer, chances are that it's not. Does it work? I'll try myself. Yeah, I think it's not working. Normally there should be. Okay, so we do it the old way. Yeah, no, it's just, it's not working. I cannot, if I click here, it's not working. I don't know what's happening here. Anyway, so just tell me, do you like recommender systems, the recommendations you get on Netflix, on TikTok, YouTube? Yeah, which one, like YouTube or all of them? You like all typically?
Yeah, typically all of them because it keeps us up to.
Okay, good. Anyone who doesn't like recommendations so much?
Normally dissatisfied with the
Any platforms in particular?
Probably very outdated content I would have watched 6 years ago, something popping up again, making me confused.
Okay. So I think that's giving a good impression of recommender systems already. Some people like it, some people don't like it so much. And there's a good reason, because recommendations are very personal often and subjective. We are not talking about that in this lecture, how to evaluate the quality of recommendations. I'm offering like an entire lecture series on recommender systems. There we talk about that. It's really difficult to evaluate recommender systems because it's so subjective. It's not like typical machine learning where you can say, okay, that's a cat, that's a dog. So if you predict that this is a dog, then it's the right answer. It's much more complicated with recommender systems. Yeah. So I'm a professor. My name is John Beal. I just to briefly introduce myself again. I'm here since 5 years now at the University of Siegen. Prior to that, I was in Dublin. So I am German. I am from Germany originally, but I was in Dublin for a couple of years in Ireland. I come originally from the area around Hanover. And my main research areas are machine learning and particularly recommender systems. And that's what we talk about today. I give you a brief. Is there anyone here who attended already my recommender systems lecture? Are you attending it right now or right now? So the next 20 minutes, you can go out or check your phone or something. You know this and already. I give you a brief introduction about recommender systems in general. What are they? How do they work? Then I talk about the algorithm selection problem. The algorithm selection problem describes the challenge of choosing the best algorithm for a given recommender system. And then finally, I talk about different aspects of graphical user interfaces for recommender systems. That's a rather uncommon topic. Typically, when people talk about recommender systems, they either talk about algorithms or maybe things like filter bubbles, impact on society, ethical challenges. But I believe that graphical user interfaces are quite an underexplored area. So if any one of you is interested, maybe in a master thesis in this field, I would be happy to discuss that. Although it's also difficult to evaluate what's a good graphical user interface. Now, introduction to recommendation algorithms. Do you know any algorithms? If you were like, I assume some of you at least have a software engineering background. Maybe you have a bachelor's already in this field. Maybe you have some industry experience. I noticed quite a few students here seem to be from Asia, let's call it in the broader context, or India. Many of those students often have some work experience already. If you were to work in a company and you were to implement a recommender system, what would be a very simple approach? If your boss tells you, we need a recommender system for our movie streaming website or for our e-commerce platform,
same movies genre in one pool, and if you just watches that movie, we'll recommend that.
Okay, that's, yeah. You could just look at the genre a movie is in, and then recommend, like if a user is watching one movie, you recommend other movies from that genre. That would be a very simple approach. You could probably implement that in a few hours, definitely a few days with testing and everything. Anything else? Maybe a bit more complex, sophisticated? Yeah, a frequent what?
Content that results on results.
Yeah, frequent content. That would maybe then be good for books where you have content, text. Maybe recommend books that have similar content. Those are all valid approaches. We talk about that in a few minutes. I just want to mention first, so most of the time in this lecture or when we talk about recommender systems, there are the obvious recommender systems, like on Amazon, where you have below the product description, like this UI element where it says customers who bought this also bought that. Those are recommendations. But there are also many non-obvious recommender systems where recommendation technologies are used, like in Google Maps, for instance. If you search on the desktop version of Google Maps for something and you search for the same thing on a mobile phone, you will get slightly different results, maybe based on your location or simply based on the fact that you use a different device. We can argue if this is a recommender system or personalized search. The boundaries are fluent often, so search and recommendations are highly related. It's always about ranking. You have, if you search for something like nightclubs in Freiburg, there's probably hundreds of nightclubs, potential items you could recommend or show, and you maybe only want the top 3 or top 5 items. Typically, search is when a user expresses his information need, like here. So the user says, I'm looking for this. And recommendations is rather if the system decides, okay, now might be a good idea to show something to the user. And there are 2 types of recommendations and of recommendation systems or classifications for this. The first one is, let's start with the second one because we had that just now, the top N ranking. So you have a large corpus of items and you want to recommend the top N items, the top 5, the top 3, the top N news articles, movies, whatsoever. Now that's like you're reading typically one article like this, and then you get here 3 recommendations. Or advertisement, it's also kind of a recommendation. The system decides typically out of a large pool of ads, which one to show here. And it decides which other news stories to show here. And then the other category of recommendations, yeah. We will talk about how the ranking is created. There's many different algorithms how you can create this ranking. So the other category is rating prediction. you maybe know this on Amazon where you give stars, or you probably don't remember this when I was your age, Netflix was around already. It was a DVD rental service, not a streaming service. And people could rate movies with stars, not like today where you can just give a thumbs up or thumbs down. And then Netflix tried to predict the rating that a user would give to this particular movie. So it's a regression problem if you're familiar with machine learning. But that's not so popular nowadays anymore. And so at that time, it was assumed if the prediction is the user will give a 5-star rating, the user will like it. The problem is very simple. In the Netflix catalog, there's probably thousands of users where you would predict 5 stars, or let's say 4 stars. So after that, you still have the ranking problem. So when we talk about recommendations, mostly we talk about the top N ranking problem. And you use, is any one of you familiar with like search ranking metrics, like NDCG? Okay, it's not so important now. Keep it, if you want to look this up, NDCG, it's a common metric to do ranking prediction. It differs from typical machine learning where you have maybe accuracy, where it's just you're counting how many predictions are correct. With NDCG, you are taking into account where the most relevant items are ranked. If you so let's say you have the ground truth and you know those are the 10 most relevant items, then you don't want to show the 10 relevant items in some order. You want the most relevant item at the top, second most relevant item in the second position, and so on, and NDCG is accounting for that. Recommender systems is not machine learning. Machine learning is one technique to implement a recommender system. Like I said, recommendations can be treated as a regression problem. Top N ranking could also be treated as a classification problem. You just predict, is this item in the top 10 or the top 5? You wouldn't have a ranking then within the top 3 or top 5 or top 10 results, but still you could do that. But recommendations, and we will talk about that, recommendation algorithms often are not based on machine learning. It's very simple, like popularity based, or like the student before said, like the category, for instance. And sometimes the data that you have is very sparse, very little. Typically, when we talk about machine learning, you maybe have at least dozens, possibly hundreds or thousands of features about an instance. Recommender systems sometimes only have basically 3 features, and that is the user, an item, and to what extent the user liked the item, like a rating or an interaction. So the user bought the item. So only three main features, and that is then being used for recommendations. Yeah, then again, like when I say here, the signals are often quite weak. What that means is, like I said before, in machine learning, you know exactly what the right answer is normally. You know in supervised machine learning, you know this is a cat, this is a dog, this was the price a house was sold for. In recommendation systems, you need to assume that if a user watched a movie from the beginning to the end, then the user liked the movie. That's a very weak assumption. Now, if a user bought an item, that the user liked the item. Again, a very weak signal. There's many chances that the user did not like the book or the movie. Maybe the user returned the book. Maybe the user watched the entire movie, but after that thought, oh my God, what a horrible movie. The probably most simple algorithm for recommendations is popularity based, and you see that everywhere. You see that on news websites. You see that on Netflix. It's like so Netflix is pricing itself for investing a lot of money into its recommender system and having, I think, hundreds of engineers working in the broader sense on the recommender system. But still, typically, at least for me, if you log into Netflix, what you see is the top movies on Netflix and the top movies in your region, like your country, for instance. Like your top 10 in Germany today, or popular on Netflix. That is relatively simple to implement, right? You don't need 100 engineers to do that. And yet, it is often being used. Any ideas why? I mean, it's easy to implement. I said that already. What are other advantages or possibly disadvantages of popularity-based recommendations?
Easy generalization for the advantage.
Yeah, what do you mean by that? Easy generally?
If everybody is watching, so that we can easily assume that that particular person or our next customer will also.
Yeah. Okay, it's based on a plausible assumption. Like, if everyone likes this, chances are high you will also like it. So and people understand how the recommendations are given. And that's a big topic in recommendations, explainability, that some users at least, they would like to know why recommendations are given. And if it says popular on Netflix, well, then you know why this movie is there, because apparently this is the most watched movie on Netflix, and that's the second most movie, presumably. Yeah, so easy to understand. Any other advantages? How about data privacy? Quite important in Europe, at least. Good or not so good?
Like in data privacy, like users' data will be like.
Yeah, so in terms of, you raised your hand?
You don't need a lot of data because it is only how much people click on this movie. So you know how much people look at this at the moment, but you don't know how who of them are looking.
Yeah, you don't need any user-specific data to calculate that. To calculate which movie is popular, all you need to know is how many users, it doesn't matter who, just how many users watched this movie. So you don't need to know their names, you don't need to know their birth years, you don't need to know what else they watched. So from a data privacy perspective, that's very good for users. From a company perspective, is that good? Why?
Because like the company the company engineers or the software engineers will don't know like which audience to target.
Right. Yeah. Well, the software engineers don't know which audience to target, but the assumption is here it's not necessary to know whom to target because it's working well, and it is working well. I mean, that's another reason why you see it everywhere, because popularity-based recommendations work well. But from a company perspective, popularity-based, so you don't have any, from a company perspective, you want to collect data about your users, typically, right? Data is valuable in most cases. So popularity-based recommendations don't give you an excuse to store user data. Now, it has the advantage that at least you are also not running into the risk that someone sues you for collecting. So in Europe, I'm not sure if you're aware of this, in Europe, data privacy and data protection is quite an issue, and the company is only allowed to store user data if there's a good reason. And not just the reason that, oh, I would like to collect the data because maybe I can use it in the future. Now, you really must use the data, otherwise you are not allowed to store it. If you have a highly personalized recommender system, you have a good excuse to say, okay, I want to record basically everything that the user is doing. Maybe even where the mouse is on the screen and exactly which passages of the movie the user is watching, something like this. But then again, other advantages of popularity-based recommendations are, besides being easy to implement, it requires very little storage. It's just, I mean, how much storage does it need to calculate to save the top 10 or 100 most watched movies? Like nothing. So even if you track for all your movies the view count, it's like nothing. It's probably megabytes we are talking about. One of the most popular algorithms in recommender systems, maybe also one of the most unique concepts for recommender systems, is collaborative filtering. In collaborative filtering, you try to identify like-minded users. Like-minded users means you have users, you have movies, and you know if a user liked or disliked a movie, or how many stars the user gave. So you see, this is these three features that I mentioned: user, item, and rating. Here, just binary, positive or negative. You see the red, or these thumbs go down. So user disliked this movie, this user liked this movie, and disliked this movie. And then, for instance, the question is, would this user like or dislike that movie? What's your assumption, just looking at this?
I guess just like.
Dislike? Yeah, so I'm not sure how you got this idea, but you could see that this and this user is relatively similar. No? Here there's the same rating, same rating, same rating. So chances are here it's also the same rating. That's the basic idea of collaborative filtering. Or you would even do the opposite. You see here the rating is different, here the rating is different, here the rating is different. So here it probably also would be different. A bit simplified. There's various ways to calculate that. You can just use correlation. You can use some machine learning algorithms and various other algorithms. Here again, relatively easy to implement. Data privacy, not that high anymore, but you need much more data of users. What's another problem here? Maybe the biggest issue in terms of how well this works. Yeah. Yeah, you need a lot of information about the liking. So what does that mean exactly for a new user in the system? There's nothing there. So, or new item, there's nothing there. So you can't recommend new items that are not rated by anyone, and you cannot recommend anything to a new user. And a new user doesn't even normally mean they made 1 or 2 ratings. You often need 10 or 20 ratings to make good recommendations. And I'm not sure how often you rate a product on Amazon or somewhere, or if you watch Netflix, how often do you do that? Like if you watch Netflix, do you know that you can rate a movie? Do you know that there's thumbs up? I think even 2 thumbs up and 1 thumbs down. How often do you do that? Not often. Yeah. So it takes, for many users, you will never have 20 ratings, and it will take a long time. Now, you don't have to use explicit ratings. You could do the same with implicit ratings, and implicit rating means you are inferring some information. So if a user watches a movie from the beginning to the end, you could say, okay, that's a thumbs up. Like I mentioned, that's a weak signal, but better than nothing. Then we have product-based recommendations, also called, so there's many different ways of classifying this. I'll just give you a broad overview. Also called content or co-usage based. Yeah.
So in the previous filter, the collaborative filter, what if a new user comes and we ask their genre, like what you like what you usually watch, like just a quick survey.
Yeah.
And based on that quick survey, we can recommend them the general idea of that particular genre.
Yeah, it's absolutely right. If there's a new user, what you can do is ask the user, which movies do you like, or which genre do you like, something like this, and then give recommendations based on that. I don't know how about you, but I find that, and some systems do that, right? I'm pretty sure you experience that. You registered somewhere, and then the system asks you either what topics are you interested in, or maybe even what particular items did you like. I find that highly annoying, but yeah, it's one way to do that, and some users probably don't mind. So yeah, it's called, by the way, the cold start problem. Cold start in terms of there's nothing there, so you need to find a way around that. One way around that is ask the users. There's many ways to cope with this. So product-based or content or co-usage-based recommendations. Content-based, I think one of you mentioned already, is really looking at the content. The user is looking at this book, and then you look at, or you recommend other books that contain the same terms, the same words. What's the advantage here maybe? Yeah, you don't need user data, not necessarily. It's again like item focused, right? Something else? It works well, no? Because it recommends items that are from the topic quite related. What's the disadvantage, maybe? Yeah.
Disadvantage, maybe it can be more it doesn't necessarily like if that particular person who read that book also read that book. So it doesn't make sense that if new user comes and he also ordered the same book, but it doesn't necessarily that he will also buy the next like the other book.
You are already one step ahead about the next part where you look at let's talk about that in a minute. So I'm really talking about comparing the content. So not anything about the users, just looking at the text. So this book has some text in the title, some text in the book itself. So you would recommend other books that contain as much of the same text as possible. The more overlap in the text, the better. So one disadvantage is sometimes you might recommend two similar items. Imagine you have a book about Harry Potter, part 1. What's the most similar book to that? Some other parts of Harry Potter. So it's an obvious recommendation. If you read Harry Potter 1, I don't need to recommend any other parts to you because you know the first part already. So if you liked it, you will just search for the follow-up parts. Yeah. Other problem, it takes a lot of storage. If you save the entire content of the book, can easily take up gigabytes, even for a small library. Now, often you need to save the content anyway to make the book searchable or something, then it's not such a big problem. But yeah. We skip this. And then the Holy Grail, personalized recommendations where some more advanced machine learning techniques are used, where you really take into account the whole user history, maybe even the sequence in which they looked at items, where you throw a lot of data at the recommender systems. Personally, I like Spotify recommendations. So I don't like YouTube recommendations as well. Just coming back to the first questions that I asked you, because typically if you search for something new, just, I don't know, if you want to learn, I don't know, how to repair some item, and then you found the right movie and you repaired your item, and then for the next 2 weeks, you always get new movies recommended how to repair that item. That's not necessary anymore. Or you are in your filter bubble, like you look for some, you don't even search for something, but you watch some video about a certain political topic, and then you get more and more recommendations exactly about that. So you stay in your filter bubble. Or maybe even if you just want to explore the opponent's opinion, and then you watch one video and you think, okay, now it's enough. I know what they think. I disagree. And then you get the same videos again, and you think, no, I don't need to watch that again. Amazon also claims that about 30%, I believe, of their revenue is coming through recommendations. That's a lot, right? I mean, Amazon is huge. They have billions of revenue, and 30% they claim is generated by recommendations. Do you believe that? Does it mean if you have an e-commerce shop and you, without recommender system, then you integrate a recommender system, you can expect 30% more revenue? You raised your hand?
Not because your e-commerce shop doesn't have billions of users around the world. They use a huge database of paying customers out there.
You know, there's some other reason that is more relevant, I believe.
We don't buy recommendations.
So if Amazon claims that 30% of the sold items were recommended prior to the purchase, it doesn't mean that the user wouldn't have bought it if it wasn't recommended. Similar to the Harry Potter. Huh? If you buy Harry Potter 1, and then Amazon is recommending Harry Potter 2, you are likely to buy it but you would have bought it anyway. So only because an item is recommended doesn't mean it wouldn't have been bought without the recommender system. From my experience, I also developed some real-world recommender systems. If you can generate like an uplift of 1% in revenue, that's already quite good. You're lucky 2%, but definitely not 30%. Amazon also claims to invest a lot of money in the recommender system. And I always show that in almost each of my lectures. I'm not sure if you are aware of that. If you click here on the top, your account, there's a separate, so you all know the recommendations that I showed you previously under, like on each article page, under the article you can buy. But Amazon also has here an explicit entry, your recommendations. What does it imply, your recommendations? It implies only for you, highly personalized recommendations. And if you click on that, the screenshot is now, I think, 3 years old. They changed this a little bit. But if you click on this, this is what I get. It's buy it again in home improvement, buy it again in healthcare, buy it again in other categories. This is all items I bought already prior to clicking on this link. So what the dozens or hundreds of Amazon engineers do with the recommender system is having this super simple algorithm. It's a bit disappointing. Yeah, again, your recommendations. If I click on this, I would expect some really new items where I think, oh wow, really, I never thought about that. I need to buy this. Yeah, I mean, I know I need at some point, I need new toothbrushes. And the point is, I'm pretty sure for the next 15 years, I don't need this again. And I hope I never need to replace the smoke alarms in my home. Maybe the batteries for it, but not new smoke alarms. They should last forever. So pretty bad recommendations in my view. Maybe you later check out how the recommendations are for you. When we talk about recommender systems, you need to have like the big picture. And the big picture is there's different classes of recommendation algorithms, like I showed you before too, like most popular, like content-based, like collaborative filtering. And within this, there is different approaches. So for popularity-based recommendation, there's not just one way of calculating popularity. You can calculate popularity simply based on the absolute count or relative count, how often something was watched. But there's also like a different variation where you take into consideration the sequence when something was watched and how popular it was after some other item was watched. So there's different ways of this. Or for collaborative filtering, you can have the traditional collaborative filtering where you determine similar users, but you can also apply it to the other columns of the table for the items. And that is then, or we skipped that. That is also what you talked about. It's a bit like this way, frequently bought together. So you are looking at which items were bought frequently together. It's also kind of item-item collaborative filtering. And then once you know the approach, you can develop a specific algorithm that takes into consideration all the hyperparameters like popularity, what's possible hyperparameters or like parameters to calculate popularity. If I tell you, please calculate popularity for Netflix movies, even maybe in Germany, what else would you ask me before you can implement that? Reviews? No, more specific really to popularity, so that you basically how to measure popularity, right? Is it the clicks or is it the views? Like, is it clicking on a movie? Is that a movie popular? Or is it watching a movie from the beginning to the end? Or is it watching a movie from the beginning to the like 90% of the minutes?
Like the number of people like that.
Exactly. Is it that people liked the movie? Is that popularity? So all these are very specific variations that you need to consider in the algorithm. And then even if you know all of this, you must to implement that. And I'm not sure, maybe it's surprising for you, but the exact implementation can also have a huge impact on how well the algorithm works. I've experienced it many times, even like in really software libraries that are created by professional software developers for recommender systems. There's different libraries, they implement the same algorithm, and yet they perform differently for various reasons. And then around this core concept, what most lectures are about as well, you have things like dealing with the recommendation corpus, how to index the items, how to store the items, how to retrieve the items. The operator or the system around there, the user interface, which we will talk about in 10 minutes or so. How do you evaluate your system, the metrics and the methods, and many things more. Yeah. Recommendations can have, so I believe I always say that, but every professor thinks that about their research field, but I believe recommender systems are really important. They have a high impact on various things. So if you are just interested in business, it has a high impact. It can uplift your revenue by 1 or 2%, which is a lot. Typically, there's not many relatively small things that can increase your revenue by 1 or 2%, or who knows, maybe even more. They have a strong impact on society and environment. Like I said before, filter bubbles on YouTube or TikTok. It really has an impact. If you would work for YouTube and you would develop the recommender system, you will have an impact on how happy people are in society. I mean, right now, many people are quite unhappy because I believe on YouTube, and especially TikTok and other apps, or X, they always get those items recommended that make them furious, typically, because that makes them watch more movies and watch the movie to the end and maybe even comment on the movie and interact with the platform. Now, if you watch a movie that contradicts your political view or that reinforces your political views in a very strong, aggressive way, you are more likely to watch more videos. So for society, for the business, that's awesome, that's perfect. You can generate more revenue, display more advertisement, perfect. But for the society, it's an issue. So if you work in that company, your design decisions have an impact. You will have to make a trade-off between the benefit for the company and benefit for society. Yeah. I mean, we're not talking about that in this lecture. Unfortunately, I should update that for next year. Recommender systems also have a strong impact on the environment as such that they use a lot of energy. If you do experiments, even just as part of a bachelor master thesis, or as for a research paper at a conference, you will create several tons of CO2 because you will use, let's say, the university clusters for a few weeks, and that uses a lot of electricity, which in turn requires coal, energy, or whatever, which produces CO2. So it has a strong impact on the environment, as all the AI systems have. Okay. Any questions so far? Yeah.
All start from.
Yeah.
So we don't have any records for all the users. How shall we start?
Well, with a completely new system, well, you definitely wouldn't start with collaborative filtering, but then you use maybe that's what we talk about actually right now, the algorithm selection problem. How to choose a good algorithm. And maybe you would start with popularity or content-based filtering, because you can do that always. Compare the content of items. Even the content of movies, you wouldn't necessarily compare the pictures, but what's the content of a movie? Like, where would you get that from?
Description.
The description, right, or the title. Maybe the actors or the director, the name of the actors and director. You could use that and then recommend movies that contain the same terms in their title or the same actor names in the cast list. Okay. That's a central question, not just for recommender systems, but for any computer system, which algorithm to choose. If you have a sorting problem, which sorting algorithm do you use? Bubble sort or quick sort or merge sort or whatever, and the same for recommender systems. If you develop a news website, a movie website, an e-commerce platform, whatever, and you want a recommender system, which algorithm do you use? Should you implement? And there's thousands of possible answers. It's not just, I introduced to you those 4 concepts: popularity, collaborative filtering, content-based filtering, and personalized. And there's a few more, so let's say 5 or 6. But in each of these categories is hundreds of different algorithms. What we did as an experiment, we implemented 5 recommendation algorithms. So the typical collaborative filtering based on users, where we identified like-minded users. Item-based collaborative filtering, where we identified items that were similarly rated. Content-based, so these are all news websites. So the content is then the text of the news article, and 2 different variations of most popular. What do you think? And then we evaluated which was best with precision. Precision basically means how often did users click on a recommendation. So we displayed recommendations with most popular, we displayed recommendations with collaborative filtering, and then measured on which recommendations most users clicked. And we assumed that the algorithm with the most clicks was the best algorithm. It's also debatable if that's true, because something like that would favor clickbait. But so what do you think, which algorithm is best? So we tried that on German news websites. That's Kölner Stadtanzeiger, that's a sport website, like here, car and motorbikes. That's a business website, technical, news, and politics. Content-based? Okay, any other opinions? Most popular? User-based? Okay, now we have almost everything. So who believes item-based? Let me show you the results. You're all right. Well, let's start from here. Huh? On the Kölner Stadtanzeiger, so it's a local newspaper in Cologne, most popular was by far the worst. That's here. And this one, it's user-based, was the best. Now the next website, Sport One. Popularity was really good. Not the best, but really good. Much better than on the website before. And the best algorithm this time was not this one, but the blue one. That's most popular sequence. And the other websites, you also see almost on every website, there's a different algorithm performing best. And in general, the performance vastly differs. And that's not unique to this. We did many similar experiments, like on real websites with real users. And it's more or less always the same observation. There's not the one algorithm that is best. How can this be? It's really annoying, right? If you do typically, like if I assume many of you have some machine learning knowledge and background, if you want to classify images, there's one best algorithm. There's CNNs, and maybe there's different variations, but you know the direction, which algorithm to choose. These are vastly different algorithms. If you compare popularity-based algorithms with content-based, that's like completely different concepts. And they perform so differently or unpredictably. So why? Why is that? Do you have any idea? No?
And the people have different intentions to go on this website. For example, Tagesspiegel, you want to learn for different topics, for example, and for sport, you are interested, for example, in only one sport, so you want to recommend the soccer teams.
Yeah, so the answer is nobody really knows for sure, but that's a good guess, or probably one of the reasons, because users are so different. The users who come to the different websites have different preferences. The items also differ. So I'm just speculating, yeah, but let's say I would assume in politics, is that right? No, it's not right. I was assuming that in politics, most popular works well, but it's not. So yeah. Okay, so most. Anyway, I assume it's relatively clear that maybe people who visit a business website have different interests and are just different to people who visit the Cologne local news. The Cologne local news website, that is probably like everyone, or like a more or less representative sample from the people living in Cologne, which is already quite a special type of people. But all the different types of people in Cologne: young people, old people, rich people, poor people, educated people, not so educated people. If you go to a business website, that's probably more wealthy, more educated people, or at least people who want to be this, people who want to be wealthy. And these people maybe have different interests. And it even gets worse in terms of selecting the best algorithm. Here we just picked one of the websites and looked at the performance of the algorithms based on the time of the day. So here's the time of the day. And you see that between 4 o'clock in the afternoon all the way through the night until 4 o'clock in the morning, the blue-white algorithm, that's the most popular sequence, performs best. And you see that then all through the day, so from 4 o'clock until, track here, until basically here or here, yeah, here, the yellow algorithm is best, so most popular. So like it's both popularity based, but a slight variance in the exact algorithm. So what does this tell you? It tells you should use 2 different algorithms. One algorithm during the day and one algorithm in the evening and at the night. But this, you can guess it probably already, this is the time of the day. It's not the only factor where you can find better or worse algorithms. If you look for the device persons use, desktop computer, mobile computer, or mobile phone, or even for age groups or gender, different algorithms perform differently. So it becomes almost impossible to manually craft some rule and say, okay, so basically in theory, you would have to say, okay, at this time of the day, for this gender, for this age group, for this device, we use this algorithm. And then for this other time of the day and the other age group and the other gender, we use a different algorithm. Then you would have the perfect performance. Now, the problem is, first of all, it's just almost impossible to do that. And what's the second problem from a software engineering view? Complexity in terms of to maintain a recommender system with maybe 6 algorithms that all use different data formats. I mean, if you compare popularity and content-based, they need completely different data. You cannot have one algorithm that is dealing with this. You need one popularity recommender system algorithm and one content-based system, which have probably different databases or data formats. And if you do that for 5 or 6 algorithms, you have 5 different data formats, possibly. So you would have a large overhead in maintaining and developing that, only maybe to get a few percentage points. But why is there not one algorithm that can just do all of it? Or will it be possible to have that? I mean, maybe there was just no person that is clever enough to do that. Or why not use large language models or just throw everything at the deep learning algorithm?
Sort of algorithm needs different sort of content of it. And to get all of them corpus in one algorithm, computation is not feasible to get that.
Yeah.
And apart from that, even if we achieve that, we need to maintain that in the real-time system. We need to update that. That's not also feasible.
Well, if you just had one algorithm that can deal with all the data formats, then the maintenance would not be so difficult. But your first point is right, that you have so many different data formats. Also, I mean, who knows? Maybe someone someday comes up with this one algorithm that can do it all. But also, if you think of machine learning, it's the same like if you were to ask, why is there not one algorithm that can work with tabular data very well and work with images very well and video and audio, and that can generate images and generate text and can do reinforcement learning and supervised and unsupervised learning all at the same time. It's just, if you just compare reinforcement learning and normal supervised learning, it's just two completely different things. You can combine them. You can do you can use reinforcement learning as a post-processing step after training a large language model, for instance. But at least so far, it's very unlikely to have really one natural algorithm that just can do all of it. And the same, in my opinion, holds true for recommender systems. Okay, now let's talk about graphical user interfaces for recommender systems. Anyone here has experience with user interfaces, like professionally, that you worked as a user interface designer or something? No? Are you all algorithm guys, software engineering guys? Okay. So if you think of a recommender system, what are the factors that you need to consider when developing a user interface? If I tell, yeah.
Maybe the cultural difference in specific country, something related to that. Like in some countries, we have to respect the culture.
Yeah, but that's more like an algorithm or like a general design decision, right? Be very specific. If I tell you, let's say for a classical news website, I tell you I want a recommender system on the right-hand side. Someone reads the news article, and then beside that, I want recommendations. Your boss tells you this. And you know that your boss is very particular, so you better ask ahead all the exact details. What would you ask? What would you want to know? Yeah. Not the position of the mouse. Really for... Yeah, so really for... What I want to ask is like a requirement analysis, or like a definition of what exactly is needed, like where exactly to display recommendations. On the right-hand side or below the articles, how many recommendations to display? 3 or 5 or 10? How much space should it take? How large should the font size be? Which color? Any additional effects? Do you want images or thumbnails or not? Which information exactly to display on a news website? The title, maybe the date, the author, the genre, category. It's tiny questions, but I will show you an experiment, they will have a large impact on how many users click on your recommendations. Yeah. How often to display the recommendations? Every time? I mean, on a news website, yeah, probably always. But in some other applications, maybe not always, if it's a push recommendation. So these are just some questions that need to be answered. It's really detailed questions. And we looked at some of them. It's a bachelor student of mine a few years ago. We called it the unreasonable effectiveness of graphical user interfaces for recommender systems. We called it the unreasonable effectiveness because a few years before there was a paper on the unreasonable effectiveness of data for machine learning, for natural language processing. Not sure. Yeah. So at that time, some people argued that instead of always developing new machine learning algorithms or natural language processing algorithms, people should focus on developing better data to train the models. And they showed that data can have a stronger impact than the algorithm. So they argued the community should focus more, or like companies should focus more on having good data than on having good algorithms. They argued the data is unreasonably effective. And we looked at the same for graphical user interfaces with the belief that the community and companies are focusing so much on developing novel algorithms, but they almost completely ignore graphical user interfaces, and they should look more into it. And it's kind of funny for recommender systems. If you talk with anyone who works in the field, everyone will tell you, yes, graphical user interfaces are important. Here's a few quotes. And some of the quotes here are like 10 years old or older. The accuracy of algorithms might be less important than the interface. The user interface of a recommender can, however, have a significant impact on effectiveness and success in practice. The funny part here is they just say that. There's no evidence to support that. There are no experiments showing, it's just blah, blah. They just say this, but there's no experiment showing how strong the impact of a user interface can be. And there is like, so we had a quick look at literature, and we found that every year, more or less, on average, maybe 2 papers are being published, maybe 3, that somehow look into recommender systems and graphical user interfaces, and typically relatively simple studies. What we also did is look at, and by the way, this would be a nice, it was a bachelor thesis, so maybe also good inspiration for you if you do a bachelor thesis or a master thesis. I believe this was quite a good work of the student. First do this literature analysis, then look at the practical aspects. So what she did was she looked at 50 blogs, popular blog websites, how they give recommendations. And she found that every recommendation displayed the title. The majority of them, 86%, showed a thumbnail of the recommended blog post. And also quite a large number had some mouse over interaction. So if you browsed with your cursor on top of a recommendation, something happened to make the user maybe more aware. And then there were a few other things, rarely, like the top recommendation was highlighted, the relevance score was shown, and other things. So what she then wanted to answer is, similar to the unreasonable effectiveness of data, should the recommender system community and developers spend more time and resources on developing and researching graphical user interfaces, and possibly less time and resources on algorithm development? And what she did is she implemented 7 different user interfaces for our own website. So this is my website, my university website, which has, I think, a few hundred visitors per day. And we don't have that anymore, but at that time we had our own recommender system here. So these things that you see here are recommendations for other blog posts on our website. That we hire some people, or that some research paper was accepted, that we gave a presentation, something like this. And we A/B tested the variations. So whenever a new user came to our website, we randomly assigned one of the 7 user interfaces to this user, and then recommendations were shown in that variation. If the user returned at some point, the same user interface was used. So 7 variations. We had 68,000 recommendations to 10,000 unique visitors. I think we always displayed 5 recommendations. You can see already that most visitors just came once. And we measured click-through rate, so how often did users click on the recommendations. Those are the 7 variations. The most simple one, just the text, just the title of the recommended blog post. Then thumbnails only, so only a picture of the recommended blog post. So whenever we write a blog post in WordPress, we can choose one picture that describes the blog post. Then title and thumbnail. So I would consider that the standard recommendations. That was, like, when you remember, when the student looked at the 50 blog posts, all showed the title, and I think 86% showed the thumbnail. So that's kind of the, let's call it the baseline or the standard. And then here we just displayed the rank of the recommendation. It's kind of not really, I mean, it's pretty obvious that this is the first one, the second one, the third one, but we just wanted to add some visual elements. And here we highlighted the top recommendation. Here we had a mouse over effect as such that if you move the cursor here, then we just had some box around it. And here we had the highlight that when you move the mouse over here, the recommendation flipped and you got additional information like the first 100 words or something from the blog post. So what do you think? Which variation is best? Which one is worst? Sorry?
Sixth one was best.
This one?
Yeah.
So 6, this one, is best or worst? Okay. Any other opinions? 4 is the best. Why?
Because first of all, we are getting title and the thumbnail. And there's one thing that I've noticed that whenever we like show the news articles by ranking them, people are more likely to click on the first or the second one.
Okay. Anyone believes that this one is best? No? Are you aware that Google displays its advertisement only as text? So, but still you think this is not best? Why?
Mostly title in the one. Because it creates a curiosity on users.
Okay. Okay, so you all have different opinions. That's good. Just as a side note, you probably don't remember that. You're probably too young. If you know the text advertisement on Google, right? You are searching for something, and then I believe first the top results, and then on the right-hand side you have advertisement, text only normally. And the history behind that is that before Google did this, all the advertisement on the internet were images, like banners, like typically more or less the size of the recommendations, but typically in this format, and often they were animated GIF images to get the attention of the viewers. Horrible, really horrible. And all the websites try to make more annoying advertisements so that the users would see it and click on it. And Google then was the first one to display only text, at least I believe they were the first ones, to only display text advertisement, and it was a huge success. I mean, obviously, you know that Google is making a lot of money from this, but it was much more effective than images. Just the plain text. Users were paying attention to this. So here's the results. So we tested that, and the result was that indeed this interactive recommendation where you could see the mouse hover effect was most effective. It had the highest click-through rate. So here, this click-through rate, 0.59%. And we didn't know. I mean, it could be either way. It could be that users click less often on this because they have more information to make a decision if they need to click. They move the mouse, the tile turns, and they can read already if this is interesting information. So we were thinking possibly this will have a very low click rate, but we were wrong. The 2 interactive versions were best. The text only was third best. And it's important to say that these differences here are very small, so statistically not significant. If you were to repeat the experiment, it could be that this one performs best. The important part, the takeaway that we took here is that some variations were significantly worse. So this has a click-through rate of 0.355 and this of 0.590. That's a quite big difference. And we can discuss now how meaningful click-through rates are, but that's beyond the scope of this lecture. So the main finding is that between the best and the worst variation, we have a difference of around 66%, I believe, in click-through rate. So if click-through rate is important for you, by optimizing, and I mean, the student she was not very experienced in web development or graphic design. So I would argue that an experienced developer can improve the web interface or create different variations in a matter of hours or days. And if you then can improve your click-through rate by 66% or possibly more, that's a really large gain in click-through rate. To improve your algorithms by 66% would typically require a lot of effort, much more than a few hours or days. So our argument was, yeah, similar like to the data, the community or the companies should pay more attention to graphical user interfaces. Now, for a bachelor thesis, this is a difficult topic because you need access to a real-world system where you can monitor this and try out the different variations. You can't do that with an offline data set. We are just sitting in front of your computer and programming and then calculate accuracy. How long is the lecture supposed to last? Until 10 or until 10? Okay. Any questions so far? Good. Then different topic, also kind of related to user interfaces. Also work of myself and a few students. Choice overload. Do you know what choice overload means? Yeah.
When there are so many choices that the user confuses, I should select this or that.
Yeah, and even worse, that if you have too much choice, your brain panics and you are not making any decision, for instance. It's
in Netflix.
Yeah, it happens in Netflix, it happens everywhere. Like if you go to the supermarket, maybe you want to buy whatever, some tomato soup. If there's just one brand with tomato soup, it's okay, right? Maybe if there's two choices, maybe you will be even more happy because you can choose between the cheap one and the expensive one. And then based on your preferences, you either have the feeling, oh, I really made a bargain, I got the cheap one, or I really got the good high quality product. But if there's 10 different tomato soups, and then you start to think, okay, that's the most expensive one, so it's probably the best. But that one's a little bit cheaper, but also looks good. And then you compare and you maybe make criteria, and you will be unhappy because you certainly will not have the optimal product in the end. You either spend too much money or the quality is not good enough, something like this. It's also called the tyranny of choice. Now, this relates to the question of how many recommendations to choose, to display in a digital library. We looked at digital libraries. What we had at that time is access to this website. There was a digital library in the social sciences, actually located in Cologne, the maintainer. So people looked at this article, and that's like their website. And we had a third-party web service. So this website was sending a request to us, to our service, saying, okay, a user is looking at this article, please send back recommendations for this article. We returned a list of recommended articles, which were then displayed here. And we varied the number of recommendations between 1 and 15. So randomly, we chose to display 1 recommendation or 15 recommendations. And we displayed 5.4 million recommendations. Recommendation sets. So as a recommendation set is like one block of recommendations with 1 to 15 recommendations. So during around 1 year. What metric would you use here to say this is good recommendation? So what we were interested in is seeing the difference between showing 1 recommendation or 2 or 3 or 4 or 15, and then saying, okay, this is better than this. Displaying this much recommendation is better than this much. Which metric to choose? Click-through rate? Click-through rate? What's the problem maybe with click-through rate? So what's better? If you display 2 recommendations and 1 recommendation is clicked, so you have a click-through rate of 50%, or displaying 5 recommendations, of which 2 recommendations are clicked. And you have a click-through rate of 40%. But you have double the clicks. What's better? Amount of clicks? But the answer is it depends, right? It depends on what you are being paid for, or what else you would do with the space. So if you display 15 recommendations, that's a lot of space on your screen. Maybe if you can display something else, who knows? We look at different metrics. This is first, again, a study, how many recommendations other digital libraries are displaying, and it ranges from 3 to 10. Most libraries show 3 or 5, but I believe without any justification. It's just a gut feeling. And this is the click-through rate. Maybe not surprisingly, the click-through rate decreases the more recommendations you display. I think that's relatively intuitive. If you display twice as many recommendations, I think it's not to expect that twice as many recommendations are clicked, especially if you consider that recommendations are being based on relevance. So the most relevant recommendations are being displayed anyway, and if you double the amount, then the lower, so let's say you display 5 recommendations, then the next 5 recommendations will be less relevant than the first 5 recommendations. It would be to expect that click-through rate goes down. This is the clicks per 1,000 recommendation sets. So the set regardless of how many recommendations are displayed. And you see that if you display more recommendations per set, the more are clicked, more or less linear. Does that help you somehow to make a decision how many recommendations to display? Difficult, huh? So that's another metric, click set through rate. I think we can skip that. And like that's how we started. And then we also said, okay, what can we do? And then we came up with other ideas. And I'm not saying that these are the perfect ideas, but that's also like part of the process, right? To think about that. So what we did here is the average, and I have to think about that. The average clicks for clicked recommendation sets. I need to think about what that exactly means. The average clicks clicked. We only looked at those sets where at least one recommendation was clicked, because very often users don't click at any recommendation, and we ignored that. We only look at those recommendation sets where at least one recommendation was clicked, and then how many clicks on average were generated. And you see here that in the beginning, if the number of recommendations per set increases, we have a relatively, so you need to look here at the blue dots, a relatively straight line occurs, like a constant increase in clicks. But then you see a decline in the slope. Then from here, also relatively constant, but at a much lower pace, the number of clicks increases. So you could argue that this here would be the right amount of recommendations, so about 6. It's just one way of showing this. Or what we also look at is the time to first click. So we measured the time, after how many seconds did the user made the first click. And you have a very similar pattern that, not surprisingly, the more recommendations you show, the longer it takes for a user to click on a recommendation. So 3.8 seconds if you only display one recommendation, up to 4.5 seconds And you see again here two lines, here and here, with a little bit more variation. But here you could argue that 5 recommendations would be a good number to display. Okay. So this is not rocket science. This is not ultimate proof that 5 or 6 recommendations are the right number to display, but it provided the first small evidence that something around 5 or 6 recommendations is a good number to display. In that particular scenario, I'm 100% sure if you try that on a different website, you will get different results. But it's worth, I believe, trying this out. If you work in a company, just measure these things and make informed decision. Okay, we go through this here quickly now. Position bias in recommender systems. Do you have any idea what position bias refers to?
Where the item is placed.
Yeah. Yeah, it refers to the tendency of users to click on the first search result or the first recommendation, regardless of how relevant it is. And there's lots of research about search in this field, but there was nothing for recommender systems. So, and this time we had 2 websites. We had, again, the Cologne website. The user looks here. We display 6 recommendations here. And we had a reference management software. So here a user manages his literature. Each entry here is some research paper the user did read. And then we display, like if a user chooses this, we display recommendations here. And we wanted to show if position bias exists. How would you do that? If you were to design the experiment, you have access to the live data. You know already that we use most of the time click-through rate. How can you prove or show that position bias exists so that users click more often at the top positions? And how could you show that this is really meaningful? You could just look at the click-through rates at the different positions, right? And you would maybe see that the click-through rate here is higher than here, than here, than here, and here, and here is lowest. Would that be evidence for position bias?
You should also randomize it.
Exactly, you need to randomize it because presumably the first recommendation is the most relevant one. So higher click-through rates are to expect. You would have to randomize, to shuffle the recommendations. And that's what we do, what we did. We shuffled the recommendations before we delivered them, or we put them in reverse order. So the least relevant recommendation in the top, the most relevant recommendation in the bottom. Again, a relatively large number of recommendations, 1.6 million 1.6 recommendation sets, 10 million recommendations. That's the overall click-through rate on Soviport, that's the Cologne website, and JabRef, the non-shuffled recommendations, the shuffled recommendations, and random. Random recommendations is just like really random recommendations from our large corpus. We did not generate recommendations, but show some items randomly as a benchmark. So you would expect something very low. Here you don't see so much. Clicks per set, not so important here. Here you see the position. So recommendations displayed in top position received relatively high click-through rates, and then they went down here. The click-through rate you would expect, or the average click-through rate, is here the dotted line. So the first result shows, yeah, recommendations in top positions are clicked more often for both shuffled and non-shuffled. For the non-shuffled, it's even stronger, the effect. Yeah? So if the most relevant recommendation is really in the first place, it receives a much higher click-through rate than when another recommendation is displayed in first position. That was on Soviport, and on JabRef, we have the same result. That is not a notch. And here's when we reversed the ranking. You see, even if the least relevant recommendation was on the first position, click-through rate was much higher. Here, this one was higher. But also you see the click-through rate when the most relevant recommendation was on the last position, the click-through rate goes up. So that shows users really pay attention. Users really look at the items and identify that the bottom recommendation is the most relevant one. And actually, I have to admit that's pretty impressive, I believe, because the corpus is 1 million recommendations, and then you pick 6 items. I mean, you would expect that these 6 items are extremely close to each other in terms of relevance, right? If you pick 6 items out of 1 million, or I believe even out of 10 million documents, my assumption would be the order doesn't matter. They would be all equally relevant, but that assumption is not true. Yeah. What can we do about this? So now we kind of proved position bias exists. So what? Nothing. There's nothing you can do about it, I believe. But it's like knowledge. Yeah? This is part of the scientific progress. You just confirm a hypothesis, and this is now confirmed knowledge. Well, that's worth something in itself. Good. That concludes the lecture. Any questions?
Sorry.
Yeah.
So, LLMs.
Mm-hmm.
So, I idea how this is going to be used now.
And there's various ways of using LLMs. I mean, you can just ask ChatGPT, please recommend a movie to me, and maybe you tell them what else you like, and it's doing quite well already. Or you just ask what are the most popular movies, and it's also doing reasonably well. But of course, you can also, there's hundreds of research papers with different ways of training LLM specifically for recommender systems.
So is it like working, or how do you measure that it's like relevant?
Yeah, that's what I try to show you with the algorithm selection problem. You always find some scenario where it's working, and then other where it's not working so well. And you measure it in the same way like all the algorithms with, well, in the live system with click-through rate. If you do just an evaluation on your computer offline, you use accuracy or NDCG, something like this. Or just your personal feeling. Yeah. Good. Thank you very much. I don't know exactly when the test will open, but I think you probably know this better than me. Good. Thank you very much.